Let's start by opening our data file. So here you can see in the variable view that there are 15 items in total used to measure selection factors. So essentially, these are the factors that the hotel believes that guests will consider when deciding whether or not to stay in their hotel. Things like courteous staff, cleanliness, decoration, infrastructure, gym and spa centers, or connected location are what they feel are the things most important to guests when deciding whether they're going to choose to stay at their hotel or not. So you'll notice that these are set up as items labeled as the following, and each one is on a scale measurement. And this is because we are measuring these items using Likert scale, which are interval scales. So scale of 1 to 5, 1 being lowest, 5 being highest. We can confirm that in the data view. So here we have the data view with our items for each observation or each respondent all the way down to 100, which is the number of responses that they collected. In this data file, they've also included a total score, which is simply the sum of all of the items added together, and that just gives an overall selection factor score. In other words, for that person, this score reflects how many of those, or the average, highest average perception of selecting those hotel amenities. So if we were to divide 39 by 15, we would get a score from 1 to 5 that would reflect that observation, right? Okay, so let's go back to the variable view, and here we have our data set, and we're going to do a reliability analysis. So a reliability analysis can be done using different types of reliability measures. The two most popular are called the Cronbach's alpha, and the split half reliability. So Cronbach's alpha is designed as a measure of internal consistency. That is, do all items within the instrument measure the same thing, right? And that's how we essentially ask SPSS to tell us, do things like the swimming pool facility or the decoration or the cleanliness, do those reflect selection factors, or are they so different that they actually aren't going to consistently measure whether people select the destination over time? I'll give another example. Imagine there was an item number 16, and item 16 was, the color of the walls in the room, right? That might have zero relationship with what factors people use to select the hotel. And as such, it would be important for SPSS to let us know that that actually has really nothing to do with selection factors criteria. Okay, so let's run our analysis on these 15 and see how they reflect reliability. So we'll go to Analyze, Scale, and Reliability Analysis. So we choose which items we'd like to do a reliability analysis of. I'd like to do for all 15 items. So we'll bring all 15 items over, and we'll choose Statistics. And here we can select a few things. So first we'll choose descriptives for items. We will choose the correlations. We can also choose descriptives for the scale. We'll leave these 4 blank. We won't run an ANOVA, and we'll leave all the other data the same as is. So here we're just selecting descriptives for items and scale and our correlations, our inter-item correlations, and hit continue. There's one more important thing you need to make sure is that when you have selected model, you've chosen the correct type of reliability test that you want to do. So in this case, we want to do a Cronbach's alpha, so we'll keep alpha selected. If you're asked to do a split half reliability or one of the other less common ones, you'll make sure you select the correct one from the box. Okay, and when ready, you'll hit OK. So here's our output. It's always going to give us our summary. In this case, we have 100 responses with 0 missing cases, which is great. We look at our, if we scroll down, actually, let's skip this for now. Let's look at our item statistics. It gives us an average mean, or sorry, a mean, arithmetic mean of the Likert scale responses, the standard deviations, and the total number of responses. So you can see here that, they range from about 1.6 to about 2.7. And that range tells us essentially overall how much they felt or how much they agreed with each of these measurement items. So if they agree that there's courteous staff, good quality of food, cleanliness, and so on. The means are useful only to a certain extent because in this case, we're not doing an analysis to look at things like whether they were really satisfied or not. That's not what our intention here is. Our dependent variable in this case is are our selection criteria, or are these measurement items reliably measuring our latent construct of selection criteria, right? This is a good check here as well to make sure that we are looking at the correct correlations. Courteous staff correlates perfectly with courteous staff, of course, and that will follow on a diagonal throughout this table. And then we'll see some interesting associations as well between the other variables. So let's go to the real part of what this test is. And this is called the Cronbach's alpha. And Cronbach's alpha, as I mentioned, is a measure of internal consistency. So if we consider the scoring for Cronbach's alpha, it is selected on a range of responses. And let me pull up here really quickly so you can see what an acceptable Cronbach's alpha will look like in the context of this study. Open that image. Sorry, one moment. Search methodology, weekly materials, week 10, and here we have the table. So according to our table, we can accept anything really over a 0.7. So 0.7 is what is called acceptable. 0.69 or less is questionable. 0.59 to 0.5 is poor, and then you just wouldn't accept anything less than 0.59. You can think of Cronbach's alpha as similar to the coefficient of correlation, or that R value from earlier in this course. Rarely do you see a Cronbach's alpha of more than 0.9. That's usually something reserved for natural or life sciences. But in social sciences, usually a number between a 0.7 and a 0.89 is an indication that we have very reliable data. Okay, so let's close that out. Look at our Cronbach's alpha. In this case, we're going to base it on standardized items. It just gives us slightly more reliability statistic, and we have 0.783. So 0.783 is somewhere between acceptable and good, and therefore we can conclude that these 15 items do effectively measure selection criteria. So let's do one last little experiment here. What would happen if we took some of these items out, right? So say we take out infrastructure, connected location, indoor adventure activities, and cleanliness, okay? And we rerun the test in the exact same way. You'll notice that Cronbach's alpha is still reliable. The remaining items still measure the selection factors criteria, but it has changed slightly, right? So it went from a 0.783 to a 0.775. So slightly down, meaning that those items that we removed actually contributed favorably to the overall reliability of that construct. In other words, those items did effectively measure selection criteria, and there's no good reason to remove them from our analysis. So next video, and the final video of this series, we will be looking at factor analysis. And factor analysis is essentially a technique referred to as dimension reduction. And at the start of that analysis, you will do a reliability analysis before you run the factor analysis. So in other words, you need to confirm that your data is reliable before you can complete the factor analysis on it. So that concludes the topic related to reliability analysis in SPSS. You might notice we didn't talk about validity. Validity is a slightly harder thing to capture in SPSS, and so it's more up to the researcher to determine the validity of the data. There are some tests we've learned in the past. Pearson's, for example, R values and strength and things like that. But really, the only way to test validity is to make sure that you have a strong and sound research program or study.